Your bank has never met you. It doesn't know your name. It definitely doesn't know your face. And yet somehow, the second a random dude in Belarus tries to buy a $3 burrito with your card, your phone buzzes before the burrito even hits the tray. How does a building full of servers know your spending habits better than your own mom? Well, it's actually quite simple. Never mind, I say that every time and it's not. I'm sorry. Buckle up. Let's start with what the bank actually needs to figure out. Every single time you tap your card at the gas station, the drive-thru, the little pottery shop you walked into because your friend made you, a question gets asked. Is this really them? And the bank has to answer that question in under 100 milliseconds, okay? Not 100 seconds, not even 1 second, but 100 milliseconds. That's roughly the time it takes for you to blink. While you are in the middle of blinking, okay, that's all that you're doing, a machine learning model is reading your entire financial life story and rendering a verdict. Which sounds insane, but also makes complete sense once you realize what that model actually knows about you. See, your bank isn't just storing your balance. It's quietly, creepily building a profile on you. Every transaction you've ever made, the Starbucks every Tuesday at 8:47 a.m., the Netflix charge the first of every month, the embarrassing amount you spent on DoorDash last month, all of it gets logged, timestamped, tagged, and fed into a model. Not to judge you. Well, maybe to judge you a little, but mostly to build what data scientists call a behavioral baseline. Your baseline is basically a digital fingerprint of your financial personality. It knows where you shop, how often you shop, how much you normally spend, what time of day you spend, and what kind of merchants you buy from. Merchant category codes, or MCCs, are little 4-digit labels that get attached to every transaction. Code 5411 is grocery stores. Code 7011 is hotels. Code 5912 is pharmacies. Your bank knows exactly which codes show up in your history and which ones have never appeared once. So when someone tries to use your card at MCC 5999, which is the catch-all for miscellaneous retail that fraudsters love because it's vague, and you have literally never shopped there in 3 years of transactions, yellow flag. Not a red one yet, but the model noticed. Now here's where it actually gets unhinged. The model doesn't just look at one thing. It looks at dozens of signals simultaneously and runs them through a scoring system in real time. Every transaction gets a fraud score, a number between 0 and 999, before it's approved or declined. Visa calls their version Visa Advanced Authorization. They process 500 million transactions a day and score every single one. Each score takes on average about 2.9 milliseconds to produce. By the way, a millisecond is 1/1000th of a second. So if a second is that, it's 1/1000. Divide that into 1,000 pieces, okay? So it takes 2.9 milliseconds to produce a score. Okay, so what's actually going into that score? Signal 1, location. Your phone told the bank where you are. Your card just said it's being used somewhere else. Are those two places the same city? The same country? Could you physically be in both places at once? In 2019, Barclays published data showing that 63% of card fraud involved a transaction happening in a different country than where the cardholder's phone was located. So if your phone is in Columbus, Ohio, and your card just tried to buy something in Budapest, the model clocks that immediately. Physics said no. Signal 2, velocity. Now, that's just a fancy word for how fast transactions are happening. Normal people buy a coffee, drive to work, maybe grab lunch. Normal people don't make 11 purchases in 4 minutes across 3 different zip codes. Fraudsters who get their hands on stolen card data move fast because they know the clock is ticking. The model knows that they know this. It's watching the speed of your transactions like a paranoid helicopter parent tracking their kid's location at prom. Signal 3, the amount. Not whether it's a big amount, but whether it's weird for you specifically. If you regularly drop $400 on electronics, a $400 electronics purchase isn't suspicious. But if the largest transaction in 6 months has been $47 at Chipotle, and then suddenly there's a $1,200 charge at a jewelry store you've never visited, the model perks up. It's less about the dollar amount and more about how far it is from your personal normal. Signal 4, and this one's sneaky. It's the 1-cent charge. When a fraudster gets a stolen card number, they don't immediately try to buy a PlayStation. First, they gotta test the card, They'll try a little tiny transaction, sometimes literally 1 cent, at an online merchant that does automatic authorization. If it goes through, the card is live. If it gets declined, they move on. The model knows this trick. A random microtransaction from a merchant you've never interacted with, followed by nothing, is actually one of the most suspicious patterns in the entire dataset. Now, all of these signals get fed into the model at once. And what kind of model is this exactly? Most major banks use an ensemble, which is a very academic way of saying they're running multiple models at the same time and combining their answers. You've got gradient boosted decision trees, which is what you'd get if you made 1,000 flowcharts and then averaged their opinions, alongside neural networks trained on billions of historical transactions. Banks like JP Morgan Chase have been open about the fact that they're using deep learning models that were trained on over a decade of fraud data. That's not a small number. That's decades of millions of people's worst financial moments turned into training data for a robot bouncer. The output is that fraud score. High score, bad. Low score, good. And the bank has a threshold, some internal cutoff number above which a transaction gets flagged, held for review, or straight up declined. Too conservative and you're annoying innocent people at the grocery store. Too loose and actual fraud slips through. Banks tune this threshold constantly based on how much fraud they're eating versus how many customers they're alienating. It is genuinely a business decision disguised as a math problem. But wait, there's more. The bank's model is not the only thing standing between you and some guy in a basement who found your card number on the dark web. Visa and MasterCard, for example, run their own fraud scoring on top of your bank's, so your transaction has to pass through the card's network system before it even gets through your bank system. So by the time that burrito purchase shows up at Chase's fraud desk, Visa has already done a first pass. 2 models, 2 scoring systems, 2 chances to catch it, running sequentially in under 100 milliseconds. Which, and I cannot stress this enough, is wild. 2 separate AI systems, each trained on hundreds of millions of transactions, are collaborating to protect your taco in the time it takes you to blink. Just think about that for a minute. This is insane. This is so wild that humans have come up with this. And then, there's the dumbest, most human part of the whole system. You go on vacation. Perry, you're at a cafe. You try to pay for a croissant. Card declined. You try again. Declined again. You're standing there doing the apologetic tourist shuffle while the waiter gives you a look that suggested he has somewhere better to be. You call the bank. They say, "We flagged it for suspicious activity." You say you're literally in Paris. They unblock the card. You go on with your life. This is called a false positive. The model got it wrong, and banks spend enormous amounts of time and money trying to minimize false positives because every false positive is a customer who almost churned into a different bank out of humiliation at a Parisian cafe. You can call ahead and set up a travel notice now, and that helps, but the model still sometimes decides that your Paris trip doesn't match your profile enough and pulls a brake anyway. The false positive rate for fraud models at major banks hovers somewhere around 0.1% of all transactions. That sounds tiny, right? But when you're processing 500 million transactions a day, 0.1% is 500,000 legitimate purchases getting declined every single day. Someone somewhere is constantly tuning that threshold, trying to catch fraudsters without turning into an annoying, overprotective parent for every person who travels internationally or buys something slightly out of character. It is a balance that no one has fully solved yet. So your bank knows it's fraud before you do because it's quietly been watching you spend money for years, building a model of what you look like in transaction form, and then running that model in 2.9 milliseconds every time you tap your card, while simultaneously comparing your location, your speed, your merchant history, your transaction size, and about 40 other signals to the billion-dollar pattern of how fraudsters actually behave. It's not magic. It's not intuition. It's a gradient-boosted ensemble model trained on your own financial history running inside a Visa data center, which honestly feels a little invasive when you say it out loud. But it also saved you from paying for a stranger's burrito in Budapest. So, fair trade. Now, that's going to cost you 1 subscribe. And if you're curious how fraudsters even come to be, stay tuned. We're going to have more videos on that coming right up. Thanks for watching.